Hello, my secondary math 1 class. So this is basically going to be how class is going to work. So since it's really annoying to try and teach in a mask, and basically you'll be getting instruction in class, and some of you might be getting this instruction while you're at home or online, we are just going to basically watch these videos of us, or of me, excuse me, filling out the notes, and then we'll have an in-class assignment, or if you're at home, an assignment that will be due if you were in class, okay? So these notes, you will have notes every single day. So basically, we will be doing examples, quote unquote, together, because I will be doing these examples for you guys. The great thing about, for those of you who are actually sitting in class, and it's actually probably really weird to hear my voice and, not have me teaching, but basically I'll be teaching, quote unquote, teaching, and I will also be able to help you as needed. I can pause this video when I need to and reiterate or explain a little more if you are physically in class with me. If you are not physically in class, then this video is available to you to rewatch, to pause, whatever you like. So if you were in my class at the end of last year, these videos will be familiar to you, but just know that these assignments, this paper that I'm working on right now, these are your notes, okay? And in my class, notes will be part of your participation grade. Okay, participation grade will be those of you who are physically in class. Okay, so online, I provide you, once I'm done filling out all these notes, this filled out notes will be online for those of you who are working at home. I still highly recommend that you fill them out, but just know that if you are physically in class, these notes will be available to you in class. So a physical piece of paper that you will fill out, you will show me that you've filled them out, and then you can either keep them, toss them. I don't recommend that because it'll help you do your assignment. So you'll keep these notes that will help you finish your assignment online. You will not be turning these in, okay? I'm sure I've already explained this to you, but just to remind you, the only thing that you are turning in, you are submitting, is going to be online, okay? You will never physically turn a piece of paper into me. I will just check to see that you've actually completed it. It'll just be kind of like your exit slip. If I know you guys weren't in my class last year. In fact, I just said if you were. You weren't, because you're my secondary 1 class. So these will just be checked at the end of class. Okay, so with that, let's get into our math. So this will be basically our first math lesson, which is super exciting. So the first thing, our first unit that we will be talking about are exponent rules. Okay, we have an entire unit on exponent, and the first one that we are talking about today is our product rule. Okay, so on your notes, let's go look at number 1, and we are going to actually define product rule. Okay, defining product rule looks a little differently in math. We're not actually writing a sentence. We're going to write out what this will look like. Okay, so first of all, we know that exponents, I'm going to put an extra word to define right here. We know that exponents, that just means repeated multiplication. Okay, and again, whatever I write on the notes, you need to be writing on the notes as well to get full participation points, again, if you are physically here in class. Okay, so exponents are just repeated multiplication. So let's do a little example right here. That means example. Okay, so we have our variable of x. That just means it's representing some number. It could be a number. Okay, x times itself. Okay, right? We're not throwing in any y's. It has to be the same base. So x times x times x times x equals x to the 1, 2, 3, 4. Okay? So now I want to kind of label this. Before we're getting into our product rule, we're just kind of defining exponents. So we're now going to label, so our x in this case was our base. Okay, our 4 is our exponent. Okay, so in exponents, you're always going to have a base. Again, this can be a variable. In this case, it's an x. Variable is a letter. We'll talk about that more. And then our exponent is that little number that's above it, right? Attached to it. Okay, so exponents, that just means repeated multiplication. It's being multiplied by itself that many times. Okay, so now we need to define the product rule. That's the first and only rule that we will be talking about today. So our product rule means when they are, or we have exponents that are being multiplied together, okay, with different exponents. So for example, we're going to write out this definition first. Okay, so we have x to the a, and I know that looks weird. It's not a number right now. It's just a number, or it's another variable that just means that it's representing something. Okay, times x to the b. Okay, this is basically just the formula. I'll explain this all in just a second. X to the a times x to the b equals x, our same base, to the a plus b. Okay, that addition sign right there is super, super important. So I want you guys to label that, okay? Our product rule, think add. Okay, we're adding those exponents. Okay, so now instead of doing a and b using variables, let's actually use a number this time. Okay, so let's use our same base, which is our x. Okay, but now let's use an actual number for our exponent. Let's say this is x squared, or x to the second power. Okay, it's being multiplied because product means multiply, right? We know our math vocab. Times x has to be the same base, and let's say this one is x cubed, or x to the third power. Okay, so what this is going to equal, again, same formula. We have our same base. Up here it was a plus b. This time it's 2 plus 3. Okay, so our final answer, we keep our same base, equals x to the 2 plus 3, which is 5. Okay, so our product rule, meaning when exponents are being multiplied, when they're being multiplied, okay, you are actually adding the exponents. Okay, add the exponents. Okay, perfect. So that's defining our product rule. When they're being multiplied, when the exponents are being multiplied together, so we see that multiplication, or they're just right next to each other, right, multiplying, that means you are adding the exponents. Okay, perfect. So let's do a couple examples down here. Let's go down to number 2. Okay, so number 2, let me see if I can zoom in just a little bit. Okay, there we go. Okay, so number 2, we see that our base, and we're actually going to write this out. Okay, so we see that our base in number 2 is 3. Okay, our exponents, we have 4 and 4. So 4 and 4. Okay, we're only talking about the product rule. So remember, what are we doing with these exponents when we are talking about the product rule? Okay, we are adding them. We are adding the exponents. Whenever you see product rule, think add exponents. Okay, in fact, I'm going to put that, let's go over here on the side of our paper. We're going to write out our steps for completing this. So our steps, add exponents. Right? We're not adding the bases together. We haven't talked about what our base is going to do. We're adding our exponents. Okay, so we have our base, which is 3 in here, those big numbers. Okay, and we have our exponents, which we have a 4 and a 4. Okay, so let's rewrite this. You can always rewrite your base. Okay, so let's rewrite our base. I'll do it in blue this time. Okay, so our base is 3. Okay, and now what we're gonna do, since it's the same base, we can just write 1, 3, and then we're gonna write our exponents. But again, what are we doing? We are adding them. Okay, so our base is 3 to the power of 4 plus 4. Okay, so maybe if you're in class right now, somebody raise your hand and tell Mrs. Campbell or me, it's so weird that I'm actually gonna be physically there, right? So tell Mrs. Campbell, somebody raise your hand and say, what would this be, right? Our base is always 3, but what is it to the power of? What goes right here? Okay, so if you want, I'm going to pause this video and somebody tell me, what is it to the power of? What is 4 plus 4? Okay, awesome. So we paused it, okay? 8 is our power, right? 4 plus 4 equals 3 to the power of 8. Okay, if you want to write that all in one color, you can totally do that. Either way. So our answer to this one is 3 to the power of 8. And if we wanted to actually solve this, right, or you could write it 3 times 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 3. 3 to the power of 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, I like it in our exponent form right there, exponential form. Okay, so that is our exponent rule with product rule. So really quick, let's look at number 3. Okay, so what is our base? Okay, probably pause it right here. Somebody tell me my base. What is my base here? Okay, our base, if you said 4, you're absolutely right. Okay, that's that big number right there. Okay, right there and there. Okay, and then what are our exponents? Somebody else raise your hand. Mrs. Campbell is going to, so weird that I'm talking in third person right now, is going to pause the video. Okay, and what are our exponents? Okay, good. Our exponents are 4 and 3. Perfect. So now what are we doing with these exponents? We have our base, which stays the same. Just like in number 2, our base was 3. That always stayed the same. Our base stays the same. So we have 4. Okay, to the power of what? To the power of, we are, boom, adding our exponents. So we have 4 plus 3. Okay, somebody answer, what is 4 to the power of? 4 to the power of 4 plus 3. What do we get? Great work. 4 plus 3 is going to be 7. So our base is 4 to the power of 7. Beautiful. Nice work. Okay, awesome. So let's go talk about number 4 really quick. Okay, so number 4, the only difference between number 4 and number 2 and 3 is that we now have a variable, right? A variable, just to remind you guys, if you can't remember from last year, a variable just means a letter, so A, B, C, D, blah, 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 a letter of the alphabet that is representing a number, okay? But notice right here, we have this 2n to the third, okay? We've been labeling our base and we've been labeling our exponents, but now we need to label a new math term. Okay, and that new math term is our coefficient or coefficients. Okay, our coefficient is a number in front of a variable. Okay, number in front of a variable. In fact, let's define that. Let's define it all the way down here. Okay, coefficient means a number in front, and when it's right next to each other, meaning in front, so again this 2 right here, that really means it's being multiplied in front, whoops, I already wrote that, of a variable. Again, the variable is that letter that represents a number, right? So let's go back up to number 4. Okay, so what is our coefficient? Our coefficient, again, is that number that's in front of a variable. So our only coefficient here is going to be 2. Okay? So then what are our variables? Okay, or in this case, I see n and n, but since those guys are the ones attached to the exponent, right? Always look at your exponent to find your base, right? Now we need to find our base. In order to find that, just like our base was 3 here, the 3 is always attached to that exponent. Look and find what are your exponents actually attached to. We have a power to the 3, it's attached to that n, and again we have a power of 3 that is attached to that n. Okay, so our base is going to be n. Okay, beautiful. Now, what are our exponents? Okay, and I'm just gonna abbreviate exponents, exp. Okay, our 2 exponents, the little numbers that are attached to our bases, right? Our base was n. We have a 3 and a 3. We have 2 3s. Okay, so over here, let's add some steps, right? So we know to add our exponents, okay? But now we just threw in a coefficient. Okay, what do we do with a coefficient? And we're not going to do it on this problem. We're going to do it on our next problem, but I still want you to write this step. Okay, so our second step is going to be to multiply coefficients. Okay, write that down, set it aside. Let's go back to number 4. Okay, if we're adding our exponents and attaching it to our base, okay, so we have our base, which is n, and we have our exponents, which is 3 plus 3. Okay, so we're gonna figure out what this power is to. Okay, so pause the video. What is n to the power of? Great job. N is to the power of 6 because 3 plus 3 is 6. So we have n to the 6. But we are not done. Okay, we still have that coefficient of 2 right there. This is where this multiplying our coefficients comes into play. Okay, well right here, there is an invisible coefficient there. Does anybody know what it is? Pause the video and answer. Does anybody know what that invisible coefficient in front of that n is? Awesome job. You might have talked about or remember from last year that that invisible coefficient is 1. Okay, in math, 1, when it's being multiplied or divided, okay, it's that creepy number that's always just there. But when it's being multiplied or divided, it doesn't have to be there because 1 times anything doesn't change it. Okay, so now we're going to multiply our coefficients. Okay, so I'm going to take 1 times 2 right here in our step 2 over here, right? We're multiplying these coefficients. Well, our coefficients we see are 2 and 1. So 2 times 1. Okay, what is 2 times 1, guys? Great job. You might have said that it was 2. 2 times 1, or anything times 1, is itself. Okay, so now we have our coefficient, we have our base and our exponent, so let's just put them together. 2n to the 6th is our answer. Okay, we multiplied our coefficients to get 2 times 1 to get 2, and we added our exponents. 3 n's over here times 3 n's over there. Okay, beautiful. Awesome. Okay, so let's do number 5 really quick. So I'm actually going to rewrite number 5. Okay, right now they're in exponential, they're kind of condensed. What we're going to write them in is called expanded form. Okay, expanded form, think of a rubber band where you're expanding it. Okay, you're making it bigger. Okay, so first thing, I'm going to write my coefficients. I'm going to put them right together. So what are our coefficients? I'm going to label them in pink. Okay, we have our coefficients, which is 3 and 2. So I'm going to put those guys right together. 3 times 2. Okay, now I'm gonna rewrite all of our exponents. Okay, so in my first term, this guy right here, I have x to the third, which just means 3x's. X times x times x. Right, we expanded it. Okay, we already got that 2 in our second term, so let's expand this exponent. Again, we have x to the third, which is 3 more. X times x times x. Okay, now let's look at our steps and follow them, right? We're gonna add our exponents, or our bases now, since we just expanded it. Count up your x's. 1, 2, 3, 4, 5, 6. So I know that x to the 6th power is going to be in my answer. Okay, let's look at our next step, our multiplier coefficients. Well, our coefficients was 3 times 2. So we know that our coefficient, the big number right in front of our variable, is now 6. And there's our answer. Okay, if you want to use expanded form, I love expanded form because you can actually see how many x's are there, right? If you didn't expand it, you could have said 3 plus 3 over here, right? Our exponents, 3 plus 3 is still going to give me 6. Okay, multiply the coefficients, 3 times 2, 6. Beautiful. Remember to always attach your exponents to your base. Our base was x. Beautiful. Let's try another one of those in expanded form. Let's go to 6 and let's expand it again. Okay, so I'm just going to rewrite from term to term. Okay, so my first term, I'm going to expand this guy, and this is 2 times n to the third, which is n times n times n. Okay, we just expanded that first term. Okay, multiply, that multiplication sign in the middle. Okay, we have another 2 times 1n. Okay, that's our expanded form again. It's almost just like we took it and we stretched it out, right? We took this equation right here, this expression right here, and we stretched it out. Okay, so now we can go back to our steps. Let's multiply our coefficients. If you want to do multiply first and then add exponents, that's totally fine. Okay, multiply first, add exponents, doesn't matter. I kind of like to do that. So let's multiply our coefficients, just because the coefficients go in front. Okay, so what is 2 times 2? Somebody tell me what's 2 times 2? Beautiful job. 2 times 2 is going to be 4. Okay, now let's count up our n's. We have 1, 2, 3, 4. 4 n's. So 4n to the power of 4. And that is our answer, right? We could have done it maybe a little quicker way. It said 2 times 2 is 4. 3 plus 1, right? Again, there's an invisible, creepy 1 right there, is 4. Beautiful job. Okay, let's look at 7. Okay, we'll do it both ways just because I don't have you guys here in front of me to get your opinion, but I'm sure on the day that we actually do this, I want to show you it both ways. So maybe you guys have already decided which way you like better. Do you like to expand it and count, or do you like to just add them up, right? So let's see. Let's do just our multiplier coefficients first. Well, do we see any coefficients? We don't see any, but what is the creepy invisible coefficient that is always there? Right? It's 1. 1 is always that creepy coefficient. So since we only have 1s, or we don't really have coefficients, we don't have to worry about number 2. Okay, all we have to do is worry about adding our exponents. Okay, so the really quick and easy way, or easy is subjective, maybe you don't think it's so easy. Okay, we need to figure out what our exponents are. So we have r to the power of what? What is that exponent right there? Again, it's the little creepy invisible number. Good, it's 1. R to the power of 1 times r to the power of 2. And I'll rewrite this so you guys can see it a little better. So we have r to the power of 1 times r to the power of 2. Okay, well, let's just add those exponents. Okay, r to the power of 1 plus 2. What is r to the power of? 1 plus 2 is 3. Okay, so we got r to the third power that way, or r cubed. Okay, but now let's expand it. Okay, so I'm going to write This is our expanded. Okay, so we have our r to the power of 1. That's just 1r, right? R to the power of 1 is just 1. R squared is how many r's? 2. 2 more r's. Okay, now all we got to do is count those r's up. 1, 2, 3. So now we have r cubed, or r to the third power. Beautiful. Same answer. Okay? Boom. So that shows us that we can do it 2 ways. Okay, so let's do just one more example. Okay, and maybe in class, if you guys are filling this out, if you want to do the last 2 examples on your own, I'll count that as bonus. Okay, so let's do number 8, okay, because there's something a little bit different than number 8. Okay, so in our previous problems, how many variables or how many letters were we dealing with? Okay, we were only dealing with 1. In number 6, it was n, just 1 n. Number 7, we were just dealing with r's. Okay, well look now in number 8. We have a couple u's, but then we have a v. Okay, this is a super important rule that I want you guys to write down. Okay, you can only multiply same bases. Okay, you can only add the exponents if their bases are the same. Only add exponents if bases are the same. In this case, our u's and our v's, those are the bases, right? We have a u and we have a v. Those aren't the same, so you cannot add the exponents that aren't the same. Okay, well let's get the step out of the way that we're really good at, or we know right now. And that's going to be to multiply our coefficients. Okay, so what are our coefficients in number 8? Those are the numbers, the big numbers that are in front of our variables. Okay, so our coefficients here are 3 and 4. So let's just get that step right out of the way. 3 times 4. What is that going to give me? Okay, nice job. 3 times 4 is 12. So we know that 12 is going to be that big number right in front of our variables. Okay, well now I kind of like expanding it. So we're going to expand the variables. So I'll do my u's in one color and I'll do my v's in another. So let's do u's in green. So I have how many u's right here? Nice, to the power of that invisible 1. So we just have 1 u. Okay, how many u's right here? 3. So 1, 2, 3 more. Okay, there's our u's. Now let's do our v's. Okay, multiplied by how many v's right here? V cubed is 1, 2, 3. Okay, our 12 is going to stay the same, but now we just have to count up the u's and the v's. Okay, so this answer is going to be 12. Okay, how many u's do I have? 1, 2, 3, 4. U to the 4th. And how many v's do I have? 1, 2, 3. Okay, and that is our answer. 12 we got when we multiplied our coefficients, right? 3 times 4 gave us 12. And then we just had to add up the exponents with the same base, right? You could have said, oh, there's 1 plus 3. That gave me u to the 4. And then there's just 1v cubed, so that one can't combine or simplify with anything, so it just stays v cubed. Okay, awesome, you guys. So that is our notes for today. Like I said, your notes, if you are physically here in class, notes are for a participation grade. These are going to help you do your in-class assignment. Okay, so if you filled out these notes with me, then please come and show me. You do not have to turn these in. This is a quick in fact, later when we're actually in class, I might just walk around and check off that you actually filled out your notes. These go into your participation grade. If you are not physically in class, then these notes, this right here, everything you see right here, will be uploaded, okay? This will be uploaded onto Canvas so that you can either maybe print it off, watch the video again, go through it so you can do that assignment. Okay, Awesome. That was our first video of the year, you guys. Nice work.